So hey everyone, welcome back to my YouTube channel. So in today's video, we'll be tackling Leetcode 2551, put marbles in the bag, a hard problem that has been confusing many coders. But don't worry, we'll break it down into step by step and find the most effective way to solve the problem. So let's deep dive into the problem. Here is the problem. So we have k bags and a list of marbles, each with a given weight. Task is to divide the marbles into k contiguous group while ensuring no bag is empty. So the cost of each bag is the sum of its first and last element. So here, as you can see, we are given k bags, and we are also given a weights of the marbles in the form of array. So here, our task is to divide the marbles into k contiguous group. In this case, we have to divide this into two group while ensuring no bag is empty. So the cost of each bag is the sum of its first and last element. So here our goal is to find the difference between the maximum and minimum possible scores. Sounds tricky? Let's visualize it with an example. So here in this given example, so we are given the weights array as 1, 3, 5 and 1 and k is given as 2. So we can split it into different ways. So one as we'll have one in a single bag and 3, 5, 1 in the other bag. So given this combination, the result will get the minimal score of that is 1 plus 1, which is the first and the last element of the bag array. So which is 1 in this case. So we'll go with 2. And for the second array, we will get 3 and 1. We'll sum it up. We'll get 4. So 4 plus 2 will get plus 6. We got the minimal score. So coming to the other combination which we get. So here it will be 1 comma 3 and 5 comma 1. So here the result is going to be 1 plus 3 and plus 5 plus 1. I hope you understood the division and how we are calculating the score. The score is nothing but the first and the last element in the subarray or whatsoever. So thus, so once we get the maximum and minimum score, we will return their difference. In this case, it's 10 minus 6, which is 4. That's what we need. That is the output that we need. So how to solve it? So instead of using brute force, so we can take a smart approach using adjacent differences. So first what we will do is we will compute the pairwise sums for the given weight, which is nothing but weights of I plus weights of I plus 1 for every for n minus 1 terms. So n is nothing but the length of the weights. So once we get the pairwise sums, we will sort these sums which we have obtained. So this by this the max scores comes out to be the k minus 1 largest element of the sums array, and the min score will be the k minus 1 smallest values. So here once we obtain it, we will subtract max from min to get the result. I hope we'll write the code. We'll go with the implementation first. So once we get the implementation done, we'll get an idea on what we are doing. I would suggest. So here first we will define them, which is nothing but the length of weights array, which is given. So if k is equal to 1, if the bag is equal to 1, we will be returning 0, because if you only have one partition, there is one bag, there is going to be no difference. So in that case, our result will be, so the max value and min value is going to be same. In that case, our result is going to be 0. So once we are done with this, we will compute adjacent pair sum. That is the step 1 of what we have discussed. So here we will take the variable pair sums, which will be weights of I plus weights of I plus 1. So for I in range, length of weights minus 1. So here length of weights We have taken a variable one plus we replace it. So once we obtain the once we obtain this, we will sort the parsons dot sort. So once we sort this, we can get the max code and min code. How we are gonna get this value? So max code is nothing but sum of k minus 1 largest values. So how we obtain this largest values in the parsons? So here we will go with minus k minus 1, which is the last k minus 1 of the sorted array, which will be the largest k minus 1. So once we get this, we'll go to min sum, which will be sum of smallest k minus 1, which will be first k minus 1 element. So once we get this, so the result we need is the difference between the maximum and this min sum. So here we will return the result as max sum, max curve here minus min here. We run this. Yeah, so this case is passed. Yeah, we're able to successfully submit, and the logic is correct. So with this approach, the time complexity for this problem is O of n log n, which is optimal given the constraints. I won't summarize the logic which we have used. So first we have compared the pairwise sums. So once we got this, we have sorted them to efficiently find max and min scores, which is used to which is obtained by the top k minus 1 and the bottom k minus 1 sums. So this technique will avoid brute force and makes the solution as possible. So I hope you find this video helpful. Drop a like, comment your thoughts, and subscribe to Leetcode for more techniques. Thank you. Cheers.